First, I introduce myself. Yes, my name is Gernot Schulmeister. I originally come from Austria. Yes, I like TYPO3 events, and I also like big data, little software architecture, and also CMS evaluations. So what's on the topic today? First, I want to tell something about the definition of software architecture. Then I want to talk something about the task of a software architect. Then I want to explain a little the process of the development of an architecture. I give some design principles, some heuristics. Then I will talk about some basic architecture styles and a little more into detail some architecture patterns. So what is software architecture about? It is about the components, the building blocks. It is about the packages as well as you can name it like you want. And it is about the relations in between these components, which are the interfaces. And then it's also about the relations to the neighboring systems, which are also very important, because if the interfaces to the neighboring systems, they're often critical in projects. If they work, then a lot of is done. And then some of the main problems are solved. And it is also about the organization of the system, which means a system consists of not only one part, it consists of more than one part, and is also of the whole life cycle of the software system, from development to changing, to running, and to replacing it by maybe another system. This is software architecture. Then the task of a software architect. What are the tasks? Of course, he has to construct, he has to make the design, and he has to help with the implementation of the software product. Then he also has to evaluate the software architecture of existing products. He has to make decisions, and he has to consult the implementation, not only the programmers, also he has to consult the product managers, the project managers, and all the other people who are concerned in the project. Then one of his tasks is also to grant the fulfillment of the requirements. So he is responsible for this, that all the requirements are met. And of course is also one of his tasks documentation. Documentation should also have an architecture, which means documentation should, there's also the principle of try, don't repeat yourself. It should only be documented in one place. The documentation should not to be too long, because it should be written shortly. It should be as well as written shortly, as well as read shortly. No one has the time to read a lot of documentation, so it's important that is short but efficient, so you get a quick overview. And then it's also important that the documentation is always up to date. You don't want to update it on many places, so you only want to update it in one place, because you have more places where you have to update, you will forget it. And everyone knows that if you have read 2 times a documentation which was not true, which were false, then you will never read a 3rd time, or you will never read it again. Yeah, and then he also have to have communication and diplomatic skills, because there are many interests, and maybe these interests or these quality issues, they are not relying to each other. They are somehow contradictions. For example, it might be required flexibility. The system should be flexible, easy to configure it, but this might cause performance issues. A lot of time performance will be slower if the flexibility rises and such things. And then one also important task is to simplify. We heard this already before. Also Matthias wants to do it with TYPO3. Usually first the systems get more and more complex, until a lot of money is invested to make it simpler again. And maybe also TYPO3 is now in this state where we try to make it more simple. And simple is always good. A simple solution is easier to understand, costs less, has less bugs, is less effort. So it should always be in your mind or in the one task to make the most simple solution. Yeah, and then he has also make the assumptions and the preconditions explicit. Also the quality issue, they have to be written down, make explicit. Although always every customer wants a high quality product, but what does this quality means? This has to be written down, but otherwise you cannot test it, you cannot check out if this has been fulfilled. Yeah, and then architect also needs to have courage, which doesn't mean foolhardiness. Courage means he has to make courageous decisions for new technologies, but giving reasons for them, for these decisions, and also evaluating alternatives. Foolhardiness is if you take the new XYZ framework, which is in the beta and stadium, and you don't check the alternatives. So this you should not do. Yeah, these are the task of architects, which, yeah. So we continue. Okay, now we start with the process of architecture development, how you build up your architecture. There are some steps necessary. You gather information, you clarify the requirements, the core task, which category is the systems, the more category, for example, an interactive system or a mobile system, or embedded systems, which also needs another architecture. Embedded systems are very close to the hardware, or real-time system, which is even another category, is quite difficult. Yeah, then you have to also identify and write down the quality targets, the relevant stakeholders, and the business and the technical context. Yeah, and then you have also investigate and look for what might the other influences and side conditions which might also have effects on the system. To identify this, sometimes there is somewhere in a manager which you don't know at the beginning, but he can influence the system, and when he says something, he wants to change this, he wants to change that, then this might cause quite impacts, and you have also gather information about this. Then you have to develop a solution strategy and make design and communicate. And of course, it's important to accompany also the implementation. Yeah, and the communicate is also very important, because they say if you make you only think that your architecture is good as long you don't have told about it anyone else. So the architecture is not something what you can make on your own, you can make alone. You should always discuss it and make it in a team. Yeah, and of course you have to accompany the implementation, always recheck, redesign, refactor, this is also important. Yeah, then we have some abstraction levels. This was also new for me. How this is done, you have some more abstraction levels. It starts with the side condition, with the environment. You have 4 environments, they say. You have the project environment with the project manager, with the organization, with the time, with the schedule. You have the product management and the requirements engineering, which set up the business case, the business value. You have the execution and the operational environment, which will be often forgotten at the beginning because you only develop, but then it might happen that if should be comes to the time everything is finished, it should be deployed and run on the operational level. Then some problems appear because you did not think in advance what will be the execution environment. And then you have also the tools and the development environment, which tools you use, which IDE you use, where the development takes place. This is also an issue. Then the second abstraction level is the architecture style and the technical infrastructure, which means the architecture style is what kind of basic architecture we'll use. For example, in TYPO3, often use is the standard is domain-driven design. Is an interactive system. You will use this, but there are some else. You can also use, for example, a model-driven design, where you make your UML models and then generate the code of it. Or there are some others, SOA, for example. But we will talk about later. Then the technical infrastructure is the servers, where will this run, where will be deployed, where is your staging server, where is your live server, where do you develop? Do you develop in a Vagrant box? Do you develop on your local host? These are the technical infrastructure. And then you come to the domain and the technical architecture level, which means the domain is your business case. And the technical architecture layer is, the domain is different in every application, but some technical, architecture details you always need. For example, security issues, you always have exception handling, you always have a logging, you maybe always have a mail shipment, a mail sending, you always have PDF generations. These are technical issues which are the same in every nearly every business case. And there you should also you should also separate as much as possible. And then you come to the program design and implementation layer, where the real programming takes place. And the process is, you do this not in a waterfall, you do this step iterative incrementally by switching through the abstraction layers. I have here also, it's maybe hard to understand, and maybe, okay, it's a little small. You can read this? No, it's too small? Okay, yes, it's too small. Yes, but this is the same I told you right now. You have at the top you have the 4 layers. At the top there's the environmental, then you have this architecture layer, this architecture styles, then the domain layer, and then the implementation layer. And you always do this iterative incrementally. You do the following steps. You make a design. You make an analysis, you design, you evaluate the design, the solution, and then you implement this and recheck this. So this you always do this iteratively and incrementally by switching through these layers, and then this is how you set up your architecture. This is maybe very theoretically, but I realized this also in our project, which we are doing now, that we implicitly do this. We are switching the layers. We have some topics regarding the infrastructure. Then we have some topics regarding the technicals, infrastructure, or some things. We have, of course, the environment layers with the Scrum things, Scrum task reviews, the product manager, which comes with new user stories. So we do this implicitly, and maybe if you watch this a little in your project, you will find out, although this is very theoretically, you do this somehow. And this is all they say it should be done. Okay. Here? No. Next. Do you think there's something true with this, or is too theoretically? You have some experience with this? Because I read this in a book. I don't know if it's really true. No, never heard. Yeah. Okay, then so we come to design principles. Yeah, then we have the heuristics. This is some heuristics, which means best practices. This is what you should do. You mix a top-down, bottom-up, outside-in strategy with hierarchical composition and decomposition. What does this mean? Top-down is you start on the basic overview and you make a decomposition in some parts, in components. You divide this in components. This is the top-down strategy. But on the other hand, you can do to the same time a bottom-up strategy where you start from the implementation, where you, for example, choose a framework, and then you start implement, and then you make the composition and put the components which you had implemented individually together. This is the bottom-up. And then you have also the outside-in strategy, which means which is also very important to start soon, with the interfaces to your neighboring systems. This is outside in. You look that the interfaces to the neighboring systems, they work, and if they work, you can also implement your system, or you implement the components. And this, this is what you can mix and how you can implement this. Yeah, then the as simple as possible principle, we talked about this already. Yeah, then it's also important the separations of concerns. The encapsulation is also somehow information hiding. So you reduce with this, you reduce the complexity for the user with this, and you put this together what belongs together. Yeah, also is important information hiding and small interfaces. It's better to have more small interfaces than one big general interface. What you also should do is regular refactoring and redesign. I also didn't know this, but it's very important in your projects that you also have a stabilization phase, where you don't make changes, but only stabilize the system by refactoring and also redesign. For example, we now do Scrum, we make sprints, but after every sprint, we have also some time for redesign. If you add something, you always have not only refactoring, but also redesign the whole application so that it might be also in future easy to change. Yeah, then you also should change the separation of business and technical aspects, which I also already mentioned. The technical aspects, logging, caching, these things you should try to separate as much as possible from the business case. Yeah, and then you should expect changes, because also the neighboring system change. This might also affect your system, and switch the perspectives, which means you have a lot of views on your system, and there's not only one view. The most important views are, for example, the building block view. This is the statical view, the view on your components. But you have also a runtime view, the main business case, how the components will be called, the call stack. But you have also the context view, which means your system in context with the surrounding system. And you have also, which is also important, the deployment view. Where does your system physically is lying? For example, what do you think? Does TYPO3 has enough views on the systems? I'm not sure if TYPO3, for example, has this a basic overview, a basic component view. I never saw something. Yeah, sometimes maybe there is one, but I'm not sure if, for example, TYPO3 offers enough views on the system that you get really, if you start, you get a quick overview how the system is set up. Yeah, then we continue with techniques for a good design. Already mentioned above, which is also the problem with TYPO3 is the loose coupling. Mathis mentioned it. He wants to exchange a component, then he finds out he has to, there are some dependency. If he wants to change this component, he has also change another component. This is one hint that the coupling is too strong. And the coupling is the number of relation of a block. Then what is also important is the high cohesion. Put together what belongs together, which means if you want to change something, you should only have to change it on one single place, not to change it on 5 different files on 7 places, and then this change will run. This is not a high cohesion. This is not a low cohesion. Yeah, then the open-close principle. I also didn't know this so good before. Which means close to changes and open for extensions, which might at the first view a little bit contradictious, but also TYPO3 I think has this with the hook system. A hook with the hooks, you can exchange it. It's open for extension, but it's closed to changes. Usually you shouldn't change something in the core, but you can extend it. Also, for example, with method parameters, you should never change method parameters, because this might cause a lot of problems. You might break anything, but maybe you could exchange it, extend it a little by adding another optional parameter, which means close to changes but open for extensions. Yeah, then the try, don't repeat yourself. Of course, duplicate code is nothing you should do. Yeah, then the inversion of control, dependency injection, which is also used by TYPO3. But it should reduce the dependencies. So this is dependency injection is somehow an universal factory, which makes for you, which creates for you the objects. You use this when you make in TYPO3 this object manager get, and then you line in the path to your class which you want to have an instance for. But I was asking the question myself, does this really reduce the dependency? Because you still have this dependency to this other class. So I'm not so sure. Also, this with this factory, this universal factory, I looked up the code. What does this do? This object manager get? Yeah, it makes some checks. If you want to invoke a singleton, of course, you should only have one instance. He checks this. Then he makes some further calls. At the end, he makes a general utility make instance. So it does not really much else, which you when you as you make when you instance when you do it yourself. Make an instance, and this general utility make instance at the end makes a new and gives over the parameters. So it does not really do something else like you do if you directly make a new and create an object. But nevertheless, it has some advantages if you use dependency injection. Although you not really reduce the dependency, you make your code easier to test if you use dependencies injection, because you by testing you can. I think I have to. When you test, you can mock the dependencies. And this, when you use dependency injection, I think a big advantage is that you can easier test it when you use dependency injection. Yeah, then of course, then you should also expect errors and failure. A system cannot be run in real time if it only handles the good part, the good way. Thank you. Yeah, you, for example, the failure first principle, that you first catch the failure, you first assume that your system is not working. You cover the failure way first, and then you implement the way it usually should work. So this is the failure first principle, which is also, I think, quite useful. Yeah, and then you have the Liskov substitution principle, which I also didn't knew before, which says a subclass always should substitute the base class, which means if you override a base class with a subclass, all the functionality which is implemented in the base class should be also working in the subclass. For example, if you have in your base class a method draw a circle, you cannot. It's bad if you override this method draw a circle without doing nothing, because then your subclass cannot do everything what the base class can do. And then I have another one, which is also, I think, quite important, is resolve cyclic dependencies. Here on the left-hand side, you have a cyclic dependency, and on the right side, you have the resolution of this, which means C, which is dependent on A, the parts where C is using A extended or are, how do you say it, are moved to another class AC, and C is now only using AC, and also the parts where C which were used by C from A are also moved to AC. So A uses AC and C uses AC, and so you don't have now a cyclic dependency anymore. And I think this is also, yeah, maybe you have also had this in your TYPO3 projects in the extension manager. For example, we also have this in some projects where in our extensions we have so many dependencies that the extension manager does not load anymore because there are so many cyclic dependencies. Maybe you have also experienced this. And I also thought about how to reduce these dependencies. And first, I thought there's some possible solution. First, you can reduce your entry points. If you, for example, you have a user extension and you have an appointment extension or a single sign-on, which are related into each other. So the appointment extensions uses a lot of times this user extension. And in the controller in many places you use this. For example, you can reduce the entry point to these extensions. There are a lot of interfaces now because it's used in many relations, because it's used on many times. You can reduce the entry points by, for example, creating a domain model for the user, which extends the user from the other extension. And within your appointment extension, you only use this domain of the appointment extension. Do you understand what I mean? So you have only one entry point, and then and you have only, if you want to exchange this user extension with another user extension, you have only exchange it on this one position. You have only this empty model which says the appointment user inherits user, which is your only entry point. You exchange this with appointment user inherits from user new user, for example. And there you have only one entry point, and you reduce a lot of the relations and the dependencies. And then you can go even a step further. For example, you have still this dependency to the user extension, but you can move this path like it's done here. The AC, you can, for example, use these parts which are used by many extensions and which have relations. You can use this, for example, move this into a base extension. So in these base extensions, they're all parts of the other extension which are used on several places. And then all the other extensions only have one dependency, and this is the base extension. So this will give you a much better, I think, overview of the system, and you can easier exchange. But this is only theory. I don't know. Has there someone experiences with this, or are there also some drawbacks? Of course, you have to do this, but I think this might be reduce a lot of the complexity of your system and make it easier, and also easier to exchange. So you can, for example, you can remove easier one extension, and you might have to fear that somewhere else in somewhere other extension this will break. Yeah, it's just an idea. Yeah, we also didn't implement it now, but yeah, you have a question?
Mostly that needs some refactoring. No, reacting on yours.
The last one?
Yeah.
Yeah.
If you start a project, you don't know that they all are all connected. It's mostly during lifetime of your project. So after that, you need time to revisit, refactor all of everything to do this.
Yeah, but this is okay. This is what I said is permanent refactoring and redesign. For example, you start with one extension, then you start with another, then you realize, okay, this second extension needs some parts of the first extension. Yeah, then is the point for refactoring and redesign. You can make this relation, but you can, for example, create then a base extension. Usually a lot of people already have base extensions which make the base setup of the whole configuration of the TYPO script. You move the parts which are used from this one extension to the base extension, and then your extension, your second extension use only this base extension. And there's no dependency to this other extension anymore. But of course, if you have already a very big system and you start with this, it will cost you a lot of time and problems. But during development, if you think about this, it will not be so costly. But and it will not take so much effort. But of course, you need to have time for refactoring and redesign, which I think is important.
Yeah, but if you do that in the start, then
yeah,
you'll probably make it future-proof.
It's not, yeah.
But you know,
It's not so much effort.
Yeah, but
yeah.
Mostly in the start you don't know what the dependency is going to be. So that's
true, but you could
it needs some lifetime to get there.
Yeah,
based
yeah,
on
of course.
you do because you
No, but you don't know the feature set for.
the architect already thinks out how it should work.
You don't know the feature set the client desires in the future.
Based on Scrum, no, but if you want to.
If you have a product and start, this is the end product and there's no new features, then you're correct. But most projects start little and grow, and the feature set grows, and then you have to refactor everything.
Yeah.
And then this is a good approach.
Yeah. This is also where I said this is with this. You have this architecture, these levels. This is where you incrementally always switch between the abstraction layers. This is how you implement. But you have with each iteration, of course, you have to redesign and refactor. And if such an issue appears, and then you can redesign and redesign your architecture. Your architecture always is not the same. You cannot plan your architecture right from the beginning. It will somehow change always. But yeah. But the thing is to keep it simple, take out complexity, and make it all this what I said, loose coupling, and this to have all these things in mind, but always with the incrementally iterative way. Yeah. This is how they say.
This could be reduced if you adopt open-close principle, right?
I'm sorry?
This could be reduced, like if you adopt open-close principle that we have discussed in previous slide, right?
The
like
open-closed? Yeah.
Like a class is closed for changes, but open for extension.
Mm.
If we adopt this principle, we can reduce like a number of these kind of difficulties, like in injection. If we like injecting one class in like one thing in a class, then we don't need to like inject in another class. If we adopt that principle, we can reduce that.
Mm.
Yeah.
Yeah. Yeah.
That was not the question. That was the
the
solution actually.
Yeah. I think so. Yeah. Okay. So we continue with the architecture styles. First, we have the domain-driven design, which is also used by TYPO3 a lot. So you have your business domain as a basis. You have your entities, which are your core objects. The entities are the things in the systems, and they have an identity, and they keep the identity throughout their lifetime, but they switch the state, they switch the properties. And then there are the value objects, who describe the entities but never change. For example, the gender is a value object. Yeah, the person might even change the gender, but the gender values itself, they will never change. If it's Mr., then it's Mr. You will never make the value object Mr. to someone else. So yeah, and then you have services, and services don't change the entities. They make operations on it, but they don't change the state. For example, service is sending a mail, but it does not sending a mail. It doesn't change the entity. Yeah, and then you have the aggregates, and the aggregates are these. They have only these are compound entities somehow. For example, you have an appointment. If you have an appointment, then you have an appointment consists of various entities. It might be an appointment consists of an event, which is an entity on itself. An appointment consists of a location. It's also an entity. An appointment consists of a speaker. It's also an entity. But for the appointment, you have only one entry point, and this is the root entry. You cannot enter an appointment or have an access to an appointment at the event level, only at the appointment level on the root object. But this is somehow a compound object. Yeah, then you have the factories in the domain, which encapsulate the construction of your objects, and then you have the repositories. Everyone knows them, where you have access to the database. So here I have this also. I hope you can. This is big enough. Yeah, a diagram of it is domain-driven design. Like here it says also model-driven design. You have the model of your business. Then you have your entities. The model describes your entities, your value objects. They are produced with factories, and the value objects are also encapsulated in aggregates, and the search with repositories. Yeah, then there's the others, which are not used by TYPO3. I just present them shortly. The model-driven architecture, where you use a model to for especially UML diagrams, and you specify your UML diagrams very precisely, and then you create code out of it. Maybe not the whole implementation, but the stubs. For example, the class headers, the method headers, you can create them with this. Then you have also quality-driven software architecture, which follows like the Deming wheel: aim, plan, build, checked. Also interesting is service-oriented architecture, where you have a service directory, where all your services are registered. And then you have a provider, which provides the services, and the consumer, which are consuming these services. And this is also a business topic, because this is also has to do something with the enterprise IT architecture, which is also a business topic. Yeah, and then you have the microservices, which are also very quite on fashion nowadays. They are quite similar to service-oriented architecture, but they have even more modularization also concerning hardware. For example, the application looks for the hardware where it will run itself. The application doesn't depend on certain hardware anymore. It's like in the cloud, you find your hardware where you can it deploys itself, and it had also not this the central service directory where all the services listed. So it also, the orchestration is very decentral and without the middleware. This is the main difference between SOA and microservices. Yeah, and then we come to the architecture patterns. We start with the interactive systems, which are most important for TYPO3, because TYPO3 is an interactive system also. And here we have the model view controller. Everyone knows it is very important. The model holds the data, the view presents the data, and the controller processes the user events and executes the business logic and updates the view. Yeah, interesting will be this. Maybe everything clear. Everyone knows TYPO3 uses M4C. But there's someone which is quite similar, to MVC, and this is the MVP. It's the model view presenter. And here, the view is strictly separated from the model. And the presenter is very thin. It only, like the tendency is to have a thin controller. And usually you don't want to have a lot of things in your controller. You want to replace it in services or something like that. And at the presenter, you have the presenter is very thin, and it only connects the controller, the view with the model. And the model also holds the business logic. And I was wondering if in TYPO3, we all say we have an MVC, but do we really have an MVC, or is it even more an MVP? I was asking myself the question. Because the tendency is like that. We want a thin controller. So is it not even already more a presenter? And do we really have, like in MVC, there is a connection between model and view? Do we really have in TYPO3 a connection between model and view? Because you can only say it in controller which models are used in the view. There's no direct relation between model and view. The only one is fluid, but fluid is only a parser. But the model cannot change the view, and the view has no impact on the model. The exchanges are only going via the controller. So my question is, maybe it's also not so important, but is it still what we use? Is it a model view controller, or is it not more a model view presenter? Maybe no one had thought about this. Maybe it's also not so important, but yeah, maybe I don't know. We can still say a model view controller, but maybe it's really, if we are more precisely, it's more a model view presenter what we are using. Also, it's also with this model view presenter, you can also, with this decoupling, you can also have a lot of views for one presenter. And this is also what TYPO3 has. A controller is always connected with a view, but a presenter can be connected with many views. And this is also something what we have in TYPO3. Because we can have the HTML view, we can also have a JSON view for the REST API or something else. So yeah, maybe we have something more like this. Yeah, what do you think about it? Is it true or is it not true? Yeah, maybe it's not so important. Yeah, then we have also the MV4M, model view model, which is quite often used in Angular, in a single page application, for example, in Angular. And this is also based on model view controller, but here we have between the model and the view, we have the view model. And the view model enriches the model for something presentation logic. In the view model, for example, you put something like infinitive scrolling. Or, for example, like you have a card and you have another card. And this another card maybe runs another browser. And you change something in this card, and then you go to another browser, and this another browser is already updated. So you have the changes from the one screen where you change in one browser, you have already the updated browser in another. And such things you can do with the view model, which enriches your model with some presentation logic. Yeah, and then we have also another one, which I thought is quite interesting. I didn't know it. Is the presentation abstraction control. This is for quite more. This is used for IDEs, for example. For PHP Storm or for NetBeans or whatever you use, one controller is not enough to control everything. Because you have a lot of windows, and this one controller will not be enough. There would be performance issues. So presentation abstraction control is used for complex interfaces. And they have some agents, and this now they had maybe I show it. They have agents, and these agents consist of controller, abstraction, and view. and the abstraction adjusts the global model to the local model. This is the principle. Maybe I show you, and this enables for parallel executions of parts of the global model. Like you have it in your IDE. For example, you change something in your main window, you add a new method, and then you already see it in your structure window. So there's some interaction between, and this is done with this presentation abstraction control. I hope this is not too small. Yeah, you see it here. You have your top level agent, which consists of control, presentation, and abstraction. Then you have your intermediate agents, and then you have your bottom agents, which are then represent the windows. Yeah, and the controller in this always communicates with the other agents. This is how it works. Yeah, and then you have there are also some other patterns. For example, from chaos to structure, the layer architecture. I think everyone knows it, 3 shift layers. Then you have the pipes and filters. It's also quite interesting. With pipes and filters, you have a decoupling of intermediate results in many ways. You have the filters. The filters processes the data, and you have the pipes, and the pipes transport the data. And in these pipes, you can also make some conditions which filter should be taken the next. And in these pipes, for example, the data is waiting for the next filter. For there's time the next filter has finished its processes, then it continues, can continue. And this is used in compilers, parsers, and image processing, this piped and filter method. Then we have the blackboard. The blackboard is used in complex knowledge systems. For example, for image and language recognition, system surveillance. The blackboard, you throw from several knowledge bases, you throw something off the blackboard with your solution strategy, and on the blackboard you find somehow an overall solution for this. For this, for example, is the blackboard pattern used. Yeah, and then we have distributed systems. For example, the broker. The broker is very much related to also to SOA. It's between the client and server. For example, you send a request to the broker. The broker is using the right service for you, contacts the server. The server responds and gives the response back to via the broker, and the broker gives back the response to the client. Yeah, here it says. And then we have also CQRS, which is also quite in fashion now, is the command query responsible segregation, where the writing on the system is strictly separating from reading. And I think this is also very useful, because for writing you have transaction security, safety. You have to need ACID. And for reading reading can be very fast, and reading is also idempotent, which means for the same request you get always the same result. And yeah, and with separating these two parts, I think you can also gain a lot of performance. And we also somehow maybe, for example, this is like it's in TYPO3 is done. You read and write on the same model, which is sometimes not good for the performance. For writing, for example, you have a form where you put in a user. This is writing. That's good. You have a model, and you validate the model, and then you put it in. But for reading, for example, you have a list of your users. For this reading, to use the same model as for the writing, I don't know if this always makes sense, because especially in list views, you don't need all the properties of the user. You will only display somehow. And there we also made already somehow a segregation where for this reading, we don't use the model, but we make a raw query, which only really selects those attributes which we only need for the reading, and not all the other ones which are in the model and which we don't need for this query. So somehow we also do this, and somehow I think sometimes it makes sense to make also a reading model where you only have the data for the reading and to separate this from the writing model where your data is written. I don't know what you think about it, but I think this makes sense. Also for performance issues, I don't know if they still exist. If you, for example, you have a user with a gender, with a title, with a job title, and you have a list of 100 users, and you use the find all methods, then you may have 301 queries, and you want to display this all in your list. Lazy loading is useful for you. You really have to query it. So you have to query for each user. You have to make a query for the gender. You have to make a query for the title and the job title, which makes 301 queries. I don't know if this still exists. Maybe Helmut. Is this still done in XSpace like this?
XSpace still fires a lot of queries.
Yeah. So you have 301 queries, and if you make a raw model, you have only one query, which with a select, and you can make joins, there's one query. So this will also has a lot of better performance. Yeah, we are finished. Yeah, I'm already finished. It's the last slide. Okay, so my conclusion. I think every developer should be a little architect. Has to be some basic knowledge of architecture. I think also the architecture knowledge gives you another view also on TYPO3. You see something with other eyes, and it gives you also new I don't know the word. Yeah, some lights find up if you look at TYPO3 with some knowledge of architecture. It helps you to understand TYPO3 better. Yeah, this is my presentation. Are there some questions still? I was too fast. No questions? Okay, thank you.